Well, yesterday we started out with side angle side known in a triangle or side 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 known in a triangle, and we were allowed to go from 3 sides to finding any of the angles, or going from 2 sides and the included angle to finding the third side. So we would either have a side missing at the start of the formula, or we'd have the angle missing at the end of the formula. Today we turn to the law of sines. When the law of sines and is very simply presented, it actually looks a lot simpler than the law of cosines when you set it up. The idea here is that you have a side on top and its opposite angle down the bottom, a side on top and its angle down the bottom. So you've got a proportion set up here, which means that if you have any 3 of the terms, you can cross multiply to solve for the 4th. So I could have 2 of the sides and an angle, or I could have 2 angles and a side, and I would be able to solve for the piece that's missing. So using the law of sines, it lets me to solve for any of these 2. Now, in any triangle, you also have a third side and a third angle, so technically we could say that the equality continues in this form, and you have what you could refer to as a continuing ratio. So taking a look at the first example, we'll start by drawing and labeling a triangle DAT. We don't always use A, B, and C. Measure of angle D is 27 degrees. We'll put that up here. Measure of angle A, 105 degrees. So obviously it's an obtuse triangle. Didn't really draw the correct triangle here, but again, the triangle setup is really what's guiding you. They're not to scale when you start with them. And I've got little side t equals 21. So I have angle, side, angle in this case. And that means I have 3 of the 4 pieces I need. I need to find little side D. That's what I'm looking for. So let's set up a proportion. It's the side over its corresponding angle is equal to, now I already have my variable that I'm going to solve for here. That means I need to know what angle D is, and I need a side and an angle that I know for this side as well. I can only have one variable in any kind of problem like this if I want to solve it. So there's my variable, there's my unknown quantity. I need to use the 2 things that I have. In this case, I have side T, but I don't have angle T. I have angle A, but I don't have side A. Well, we want to think about things we know about triangles. We know that we have angle A. We know that we have angle D, so that immediately gives us a third piece of information that we haven't put inside the triangle yet. What that gives us is a third angle, because you know that all the angles add up to 180. So I've got a total of 132 so far. That means I've got another 48 degrees that I can put into angle T. So now I've got 2 pieces that I need. Now I know what angle T is and I know what side T is, so I can put 21 here, a little side T, and I actually want to set this up with the letters first. I'm going to be using side T over angle T. And I suggest you do set it up with the letters first, because you're not always going to have A's, B's, and C's. Even when you do, things move around on you. So if you just set that up and then do a direct substitution, might help you out. So it's D over the sine of 27 degrees, we know what angle D is equal to 21 over the sine of 48 degrees. And 75, yeah, that does work out. Okay, now it's time to cross multiply. D times, we're cross multiplying, sine of 48 degrees is equal to 21 times sine of 27 degrees. Important to realize here, just like in the law of cosines, when we kept cosine of an angle as one unit, that we can't split up. We can't send the word sine one way and the argument the other way. That has to stay together. It's a function. So if we want to get D by itself, it looks like we're going to need to divide by this entire function on both sides. That's what I'll do. I'll divide by the sine of 48 degrees. And I'll do the same thing on this side. That means that this cancels with this, and I'm left with D all by itself, which is, after all, my goal. Keep in mind that when you see sine of an angle, a function with an argument, this is a number that you can get out of your calculator. So is this a number that you can get out of your calculator? So we'll pick up the calculator. Since you're working all in degree angles here, you better be sure that your calculator is in degree mode. I'm just going to verify that mine is. Go home, check settings, document settings, and I'm in radian mode. Good thing I checked. I'm going to change that to degree, say make default. Go back to my document. Go to current. And now we'll type exactly as you see it, a fraction. On top it's 21 times the sine of 27 degrees. We'll go down the bottom. On the bottom it's the sine of 48 degrees. And we'll hit enter. And we come up with a number. It's not a degree measure, it's just a number. It's 12.829. But after all, we were looking for the length of a side, so it shouldn't have any degrees on it. We should have rounding instructions for a problem like this. If we round it off to the nearest tenth, then we'd be left with d is equal to 12.8, whatever units we have in the problem. Keep in mind you have a number of things that you've learned in geometry class. Supplementary angles add to 180 degrees. Complementary angles add to 90 degrees. Supplementary like the sunrise. Complementary like a corner. Angles of triangle adding to 180. The shortest side is opposite the smallest angle, which means the longest side has to be opposite the longest angle. And inside of a parallelogram, the shortest diagonal is opposite the smaller side. The longer diagonal is opposite the larger angle. And the last thing about that we might have to use in this unit, adjacent corner angles add to 180 degrees. So if we add this angle here to this angle here, we come up with 180. They'll be important when we get to the parallelograms.